Okay, so before the break, we were talking about those discussion boards and debugging assignments. And yeah, I'll adjust the points because some of that might have been very quickly. I'll show up very quickly. So I don't want to penalize people right off the bat, but hopefully what's going on with those debugging assignments and kind of made sense, because there's going to be a lot of that. Only it's going to be in the algorithms we put together. So the main thing this class is about, what we're really doing here, is learning problem solving. So all of those things we do, like that first set of debugging assignments, determining miles per gallon, that's a problem that we can solve. Or figuring out what a 10% discount on the price of an item is. That's a problem that we can solve. And in particular, the reason it's showing up here is it's a problem we can solve with a computer program. And so really what we're looking at here is problem solving and putting together algorithms, which the definition of an algorithm is a finite set of steps necessary to achieve a desired result. So the steps we have to take. And we study that in terms of programming here, because programming gives us a way to put algorithms together and immediately see results, see if they work or not. So we'll start off here just talking about some things about programming in general. Or sorry, not programming, about problem solving in general. In particular, what tools do we have to solve problems with? Obviously, your mind probably just now jumped to programming languages, because that's what we're doing here. But how do we know those programming languages can be used to solve a problem? And in order to solve a problem, there's this concept called four constructs, which is essentially the four types of tools we need to solve any sort of problem. It's been mathematically proven that these four things we're getting ready to list out can be used to solve any problem we might face. So the first one of our constructs is a sequential construct, which is an order for things to go in. We need an order to carry out the steps in order to eventually reach a solution of the problem we're facing. Be it programming, like we're studying in this class, or picking up groceries on a day when our car is broke down. Right? Some sort of problem that we're facing. The tools we have to work with are four constructs. We need an order for steps to be carried out in to solve that problem. The second construct, I'll write selection. And I plan to write these words up here several times. That doesn't look like an E. So I might use slightly different versions of the words that mean the same thing, but along with a sequential structure, we need a selection structure, a way to make choices along the way, take different branches. That way we're not exactly following the same path, and take different branches to find the path that leads to the solution to our problem. The third one is reiteration. We need a way to repeat steps if necessary. Some problems, there's going to be might be a lot of steps that need carried out, and not necessarily exact repetition. Sometimes it might be, but usually this refers to repetition or reiteration with variance. The example I always like to think of is mowing your yard with like a push mower. Right? Get your mower out, get that started up, and you mow a strip of the yard. Or repetition, doing the exact same thing, you'd go back and mow that same strip of the yard again. Then go back and mow that same strip of the yard. So there's no progress being made. We need to repeat with variance or reiterate with some sort of variance to what we're doing. So in the case of mowing, and get your mower out, you mow a strip of the yard, then you turn around and move over and mow the next strip of the yard. And that way, eventually the entire yard does get mowed. So repeat things, typically with some variance in it, is necessary for reaching the solution of a problem. And then the fourth construct is invocation. And invocation refers to, it kind of goes with the sequence. We need a way to step out of our sequence, do some other stuff, and then come back to the spot we were. Right? I think I'll take an example of a problem might be going and getting groceries on a day when your car's broke down. Well, the sequence is going to be find somebody that can give you a ride to the grocery store, choose all the groceries you need, then there might be, we can look at it as reiteration or invocation. After getting all the groceries, you might realize some other stuff that you need and should probably pick up while you're there that weren't on your original grocery list, right? Like, oh no, it might be a couple days before the car's fixed, so better pick up some extra paper towels and soap and toothpaste and the stuff that's really expensive at the grocery store. So we usually go someplace like the Dollar General to get it because it's half the price. But go ahead and pick it up while you're there. So it's like stepping out of your sequence, doing some other stuff, and then coming back to the same spot you are in the sequence. So that's kind of the tools we have to work with, our four constructs. The sequential construct, a selection construct, a reiteration construct, and an invocation construct. And we know that whenever we're faced with a problem that a computer can solve, we can solve that problem with a programming language because all of our programming languages have these four constructs. And we will study them throughout the semester, the different pieces, and we'll see how they go together. And like I pointed out, it's not just computer programming. All problems can be solved with these sort of tools. That big famous one of world peace is only going to will be solved with four constructs. It's just currently nobody's come up with the right sequence of events and the right choices to make and repeat those correct choices and make adjustments as needed to achieve that particular goal, famous problem of world peace. But we know it can be solved with just those four things. So that's what we've seen so far. The first one, right? Back to that little bubble that I drew. And we'll draw a few times. Because that's really what we're doing in this class, is filling in this bubble. It started with just some input and output stuff. What's a good example? Oh, the discussion board, that intro discussion board that we put together in Raptor. Our input for that, everything was internal to it. So our input was really just starting the program. And then we had a bunch of values stored in there. So there was a bunch of stuff going on, stored in RAM. We stored it in RAM and then retrieved it for RAM. So that's our sequence so far. We have a sequence of hitting that run button, storing a bunch of things in RAM, and then outputting the sentences. So we have, I'll use arrows here and whenever we're drawing this picture to kind of fill up the sequential structure of the logic we're studying. Some sort of order that those things need to happen in. We were talking about that earlier with the debugging things and the steps we have to take. They need to be in a certain order for the computer to carry those out. But that might not be the same order we think of it in. Right? I pointed out with the assignment operator, it only goes one direction. So when we had, I'm going to abbreviate it here, when we were putting that together, when we wrote final price equals original price minus discount, the assignment operator in programming languages typically only goes from right to left. So the computer has to have it in that sequence. But when we're thinking about it, it doesn't make a bit of difference to a human if we put it the other way. It's fine for us to think the original price minus the discount gives us the final price. So we have to make that adjustment with programming and make sure we're keeping things in the right sequence. This is the sequence that the computer needs it in. So that's the first one of our constructs that we're going to be looking at. And then here, next week, we're going to talk about math stuff. We're going to learn how to understand binary code, what those ones and zeros mean. Some simple problems, like the most complicated thing is you'll see some questions that have a whole bunch of ones and zeros, big long string of ones and zeros, and I'm going to tell you their words and ask you to tell me what words those ones and zeros represent. But by that point, you'll know exactly how to do that. And we'll also do some math with it, which at times in the past, this course was named computer math, because that's one of the main things we learn in it, is how to deal with those ones and zeros and the processing that's occurring on the inside. Right? Is it okay if I erase this picture over here? Just kind of pointing out the symbols. We've started studying the sequential structure. We run the program or get in. I guess I could fill this in with the one we just did. Our input there was the price. We got a price from the user. We did that calculation to get the discount. And then after getting a discount, we did the calculation to get our final price. And then we output that. So there was a definitive sequence we went through, a sequential structure. So we're going to talk about that and kind of get started with things tonight and a little bit next Monday. But then we're going to talk about math for a little while. As you might remember, on the first day, I drew out a box listing out the parts of a central processing unit of the CPU. And there were a few pieces in there. We had a control. We had some RAM. There was a clock in there. I think I drew that over here. Trying to remember what all order I had them in. Control unit, the RAM, the registers. I had to think about that for a minute because this box just shows the pieces there, and I wanted to make sure I put them in the same order I did on that first day. But then the other two pieces that we had was an arithmetic logic unit, which I mentioned that day is the electronic piece that adds two whole numbers together, and a floating point unit, which is the electronic component that adds two decimal numbers together. They look very similar. We'll see it when we get probably next Wednesday, that they do the exact same thing, only one goes left to right and the other one goes right to left because of how we increase whole numbers versus how we increase decimals. But the pieces we have only do math. And it seems like we've already been doing stuff that's not math, right? Like when we put strings together. doesn't seem like there's a whole lot of calculation there. So we'll go over a lot of that. And when a computer processes, I guess the main point is that it's doing math. So at times in the past, this course was actually called computer math, but giving it that name seemed to make people panic. So they switched it back to logic, which is a synonym for math that doesn't make Americans panic. It's just that word seems to be enough to bring in some panic, make some people start to panic. But before we get into the math with the ones and zeros and the binary encoding next week, well, when we're doing process or simple things, we want to do some basic math like we saw in those debugging assignments. So let's start with a couple quick examples on our basic math operations. I'm going to write the word normal math operations, the ones we're used to. Essentially, we're going to use our program like a calculator to see all these things, normal calculator buttons. So we'll have, we'll add things and subtract things. And typically we use these symbols, add, minus for subtract. We'll use an asterisk to multiply. And exponents tend to vary language to language. Some languages we use 2 asterisks to do an exponent. Some languages we use a caret, which actually means something different that we'll talk about 2 Mondays from now. No, 3 Mondays from now when we get to the logical operators. So we just take advantage of the fact that it produces an exponent. So sometimes we use 2 asterisks for an exponent. Sometimes we don't have an exponent, and there's this fancy little trick we can do to get exponent out of the language. We're going to usually multiply, and the 2 languages we'll be working with, we can use either 2 asterisks if we need an exponent, like squared or cubed or raising something to some power. Python, we can use 2 asterisks or a caret, and in Raptor, we'll use a caret for putting our code together. Division is typically the slash, and in both Python and when we draw the flow chart so that the computer can write the code for us, we'll use a division for floating point, a slash for floating point division. That's what a calculator gives us, where we get the decimal, and floating point just means the decimal moves to wherever it's needed. So that will give us a number with a decimal. And in Python, I'll write this out specifically. In Python, we can also use 2 slashes for integer division. Which is where we get just the whole number part. So like back in elementary school, when we would divide numbers, say if we divided 13 by 4, that goes 3 times, minus 12, and we have a 1 left over. So floating point division, that's where we would add a decimal here and then start doing the decimal things. Whereas integer division, that gives us the 3, and then we'd have a remainder left over. So we can either express that remainder as a floating point number, all the little fractional part, or as a remainder itself. And to do that is the modulus operator. It's usually the percent sign. In most languages, it's going to be the percent sign. Python uses the percent sign, but if we do that in Raptor, it was originally written in a language called Perl, where for some reason they used actually wrote MOD. There's a lot of useful tricks that come with that. That's one that might seem strange. So modulus gives us the remainder. So if we did these two things, 13 divided by 4 is 3 with a remainder of 1. So it's okay if I erase this side? I ran out of room to write with.
Yeah, that's fine.
Again, I always like to check that because I don't know if people are following along with notes and things. I guess it's not as big a deal if there's a video because we can check back on the video. But those divisions, so if we did 4 floating point, that's backwards. Sorry. If we did 13 floating point division by 4, what do we get? 3.25? Is that right in my head? At least it's 10 minus 8. Yeah. Yeah, 3.25 with the floating decimal point that floats back and forth to wherever we need it. And I'll use the Python notation. So 2 slashes is our integer division. So 13 integer division by 4 would give us 3. And we ignore the remainder part. So it just gives us the integer part, and then 13 modulus, or 13 mod 4, it gives us just the remainder, which in this case, we have a remainder of 1. So if you want like the quotient remainder type of answers, which can be very useful, we use integer division and modulus to get those. And there's a lot of other tricks where modulus comes in handy. You probably haven't seen them because for some reason they don't show up until higher level math classes. But we can work with, when the remainder is the part we want, we actually call it a residue, if the remainder is what we want. So we can work with residues the same way. So we have 13 up here. I'll do a simple case. So like 13 plus 7 is 20. But if we divided all those by 4 and only worked with the remainders, so 13 mod 4 gives us a remainder of 1, plus 7 divided by 4 would be 1 with a remainder of 3, right? Which 1 plus 3 gives us 4, but 4 divided by 4 is 1 with a remainder of 0. And so 0 and 4 are kind of equivalent if we're looking at residues. And what's our remainder if we do 20 divided by 4? It comes out nice and even, right? So there's a lot of tricks that we can do. Probably haven't seen it unless you've gotten to some high-level math classes, but we can do things with just the remainders, and it's still equivalent. So that's a very useful one. When it shows up in programming, one thing I always like to say to people, to kind of a suggestion to just think about things and try to make sense of how to use that, because you probably haven't used that wanting the remainder before, is think about a vending machine. Because a vending machine only can give change only using the modulus operation. So all the programming to run a vending machine needs to give correct change in all those different coin values, right? We have pennies, nickels, dimes, and quarters, and the machine figures out how much we need of those to add up to a certain amount. All it needs is the division. So for a little thought exercise, see if you can think through why that is enough to do a vending machine. That's the one I always like to point towards to get people thinking about that. Does anybody have any questions about that? That's our basic operations. Add, subtract, multiply, divide. We have a couple types of division. For the most part in this class, floating point division will be fine. And then sometimes we'll do things where we want the remainder. But since you probably haven't seen that much in your math class, you might want to just think about a few things to think through some situations where that's nice. And I like the vending machine one. Think through why a vending machine only needs to know what the remainder is, do the division operation, and only deal with the remainder in order to give correct change. Just a fun little thought exercise. Let's see, what time is it? 7:50. So let's look at doing some of this very quickly in, well, I guess Raptor and Python. We'll kind of look at both of them. Does anybody have any questions? I think everybody's used a calculator before, right? So essentially, we're going to make a program that's like a calculator. I thought I heard somebody ask a question, and then it went back to muting real quick.
Wait, is that one you to do with the calculator? Is that one of our assignments?
No, that's just what I was we're just gonna do that as a quick example to see these real quick.
Okay.
Essentially, that's what we're going to do. Historically, one of the first computers, I guess it's like the 1947 model of the electronic, once computers moved to electricity, was called EDBAC. It's an electronic discrete variable. I can't remember what all the letters stood for, but EDBAC, the C there stood for calculator, not computer. So that's really what a computer is. It's a glorified calculator. So a nice simple example for class here seemed like, well, let's make a calculator. So we talked about planning the other day, and you all saw the pseudocode. We talked about that earlier today. So I'm just gonna jump in and start making stuff this time. I'm gonna go ahead and share my screen. And I guess we'll do it in Raptor first. So I'll pull this back up. I'm gonna hit a new one. Can everybody see my screen?
Yes.
Okay, so what do we need for a calculator? Actually, I'll do the pseudocode here this time. Because we haven't talked about comments. I often forget to talk about comments because as you progress further and get into higher languages and more stuff, there are encoding schemes that we can put in comments of our code that will generate web pages. So it's like another programming language that goes into the comments, which are code that the computer ignores. It's like notes for the programmer or anybody that might be looking at the code. So the computer ignores those when it runs, but we can put other encoding schemes there, and it's very common to put encoding schemes that will generate entire websites describing our code instead of just a little bitty note there in the text file that you have to look at the code to see. So I usually focus on those a lot and tend to forget comments, but it's a good place for pseudocode. What do we need for a calculator?
Numbers.
Numbers, yep, exactly. So we need two numbers. So get, well, I'm going to use X and Y. That's our numbers. Right? Get X, and we'll get a Y, and then we can do our math, right? I'll just put them into Z. So then like output Z equals X plus Y, output Z equals X minus Y, output Z equals X times Y, I'll put z equals x divided by y. And I'll just do the 4 for now. The modulus operator is in there. We have to actually spell it out in Raptor, which seems like a good place to point at this. Remember, like most software, Raptor has this nice little help button up here, and their help button is fairly thorough. So there's like sections about the math operations. And remember that that's there if we need it. So exponents, multiply, divide, and then we can either use remainder or mod. Actually, I have to spell them out in this, but I'm just going to do the 4 basic operations for now. We also have exponents and modulus. But there's the pseudocode, the design, the plan of what needs to happen. So that first step there, and notice it's written in green, that's not part of our flowchart. It's just an extra little comment to help indicate what's going on there. So the first step, get X. Anybody remember which shape we need to get a value from the user?
An input.
Mm-hmm. So one of our input parallelograms, and we can either drag it over and click here. Oh, I got to save. I always forget about that time limit. Mash the keyboard. If you're following along, you might want to give it a better name than just mashing the keyboard like I did there. That way you can keep track of which one's which. But so I've selected over here and then clicked where I wanted it to go in the flowchart. And with our input, we always have to tell the user, make it very clear to the user what we want. So enter the first number. And I always like to end prompts with either a colon or a question mark, depending on how it's phrased. This one's just a statement, so there's a colon. It's kind of hard to see there, but when we get back over, after I hit done in a second, it'll do that. And this is just basic math, so I'm just going to call that X. The question showed up earlier about names and stuff. Our only restriction on how we name things is it has to start with a letter, and we cannot have spaces. So first off, a letter, no spaces, and for the purposes of this class, let's just go ahead and say no special characters. Because that changes language to language, which special characters we can or cannot use. So an underscore is the only special character. So if you wanted to write your name, write the names with like, what did we see earlier? Original price, split that up into 2 words and do original underscore price, that would be okay. You just want to be careful with no spaces, and special characters mean things to programming languages. So we don't want to use just any special character. Can you all hear me?
Yes.
Yes.
Yeah.
Okay. The screen was looking funny, and like it was delaying and things, so I wasn't sure if it had a bad signal or something. But yeah, so it just has to start with a lowercase letter and no spaces, and let's avoid special characters except for an underscore in this class, because that is language specific. So that gets us 1 number, and then that's highlighted, so I can just click here. I haven't shown copy and paste yet, so I'm going to do that, which is a little bit of extra step here. But if I click on that symbol there, Control C, the regular copy shortcut on the keyboard, Control C gets it on the clipboard, and then you have to click where you want it to go. Oh, that's still selected. Click where you want it to go, and then hit Control V to paste it. So there's an extra clicking involved in copy and paste. Let me bring in another symbol. So like if I bring in another couple more symbols so we can see it. If I want to copy this one down to the bottom, First off, you also have to make sure nothing's selected over here. Hit Control C, or if you right click, there's a copy. Control C to copy, and then click where you want it to go, and then hit Control V to paste it. So you do have to indicate where it goes before pasting. And make sure nothing's selected, because then when you click somewhere, it'll put something else there. So if I copy that, then click down here and hit Control V, it pastes it right there in that spot. And then we can go in here and just edit that. Enter the second number, and we'll call that Y. And that is something you'll want to do a lot, whether you're in Python where it's all text, or in Raptor with the flowcharts. Copy and paste is almost always better, because humans are very prone to making typos, and the computers are not. So we want to minimize the amount of chances we have to make a typo. Like here, the only difference between those prompts, or between those two, is one of them prompt said first, one of the prompts said second, and then our variable had a different name. So instead of typing the whole thing, I'm just going to copied and pasted and just made those couple changes, because that cuts down the chances of me making a typo. We'll get those, and then to do our math, it's usually an assignment statement, or we can do it right in the output. I'll do it in the assignment, because normally it's better form to break things down into more steps. Don't ever worry about how much work you put onto the computer. More simple steps is usually better than fewer complicated steps. So I'll go ahead and create this variable called Z, and set that first to X plus Y. And in this case, those spaces I put in there are only for my benefit. If I just did X plus Y jammed together, the computer would know what to do with those. But that's harder for me to read. If I need to come back and adjust it or edit it or something like that, then it's I want it to be easy for me to read. And then finally, we need an output. Oh, something in the chat room. Yes, that would be better, but we would have to get to selection structures, because we would have to ask the user which operation they want to do and then choose between them. So I believe that is homework in week 5 or 4. I think week 4. That is actually one of the homework assignments. So there was a question in the chat room of wouldn't it be better if the user can input their own sign? And it's already erased from the board. But in order to do that, that would be better, but we need the selection structure. And we won't see that until after we talk about all the binary code. So we're just kind of looking at a sequence here and just going to do all of them. To just kind of get started with the symbols, get used to putting these things together, and then we'll get into the math stuff and all the theory things over the next 2 weeks. Which in the past, we did all that stuff first. So I think whoever did the statewide shell for Ivy Tech decided to move some programming up to the beginning. That way there's something to do, right? While we go over all that theory, you can play around with programs and make things happen in order. Yeah, so far all we've seen is the sequential structure, a sequential construct, which is something built into every one of our languages. When we input stuff, it is typically a top to bottom. Well, in this case, at this point, it's top to bottom. We'll learn to jump around before long, but that's our invocation thing. We leave that top to bottom order and then come back to it. We'll see that soon. So yeah, built into all our languages is a sequential, and the sequence is the order that we type the steps in. So then we'll output. I'll put the word sum. plus Z. Obviously, there's much better ways to do that. I started to build up a bigger string, like the sum of whatever's stored in X and whatever's stored in Y is equal to Z would be a much better output, right? A nice descriptive, full, grammatically correct sentence. The reason I went with the short version is to avoid clutter in the example, because this is just an example for class, so I don't want to overly clutter it. And we've seen how to, well, this even has concatenation in it. We have one example of concatenation, but obviously better outputs would have multiple concatenations in, where we say what numbers we're adding together to get that, and make it clearer, but I'll skip over that for now. And do a copy and paste for the rest of it, because we have an assignment and an output, and that's what we need for the rest of these things in the pseudocode, right? Assign the difference between them and output that. Assign the product of them and output that. Assign the quotient of them and output that. So I'm just going to draw a box to select both of those at once and hit Control C to copy. And then paste down here at the bottom, 1, and click again at the bottom where it needs to go, 2, 3. And I just pasted 3 of them in to finish out this algorithm, the pseudocode up here. And pseudocode, remember, that means similar to code. It's very informal. That is a personal tool. It's just to help you get your thoughts straight, get everything organized and put it in the order it needs to go. Halfway between the language you speak and the language the computer needs. So it's a personal tool, very informal, but you kind of want to be thorough when you put it together and make sure you have everything planned out well. That way it can apply to any language. Now I'm just going to scroll through here and edit those. So after finding the sum, we'll come through and find the difference. And then the output doesn't change. Oh, wait, yeah, it does. The output needs to label. It's not a sum, it's a difference. And I'll just do some abbreviation here to kind of try and minimize the clutter. After we find the difference, multiply, and then change the label in the output. And again, copy and paste is very important. Computers never make typos. Humans make typos. If the computer types something wrong, it's because we told it to type something incorrectly. So copy and paste as much as possible and minimize the amount that you have to change, because then that minimizes the places where a typo could work its way in. Does anybody have any questions about that? Does that make sense? What's going on there?
Yes.
Okay, and for the Raptor programs, when you go to assign them, when you save it, if I go to where that's saved in my delete folder, you can just turn in that Raptor file. And you may have noticed by now, Raptor really likes to back things up. So you can just go through and delete the backups. Which one is this? HBJN. So you might want to give it a better name than what I did there, but in the 5 minutes, 10 minutes we've been working on it, Raptor already decided to back it up 3 times. So you'll want to go in and clear up those backups occasionally if you think it's okay. And then just submit that file. On that first discussion board, I said to turn in pictures, but that was the only one for the picture. The rest of them, just go ahead and turn in Raptor. And the picture was so you could share it with your classmates, really. I guess we should run this and test it, right? The whole development process for the waterfall method. We came up with a plan, carried out the steps of that plan. Now we need to test it and make sure it works right. And we want to check things that we can confirm, right? So maybe I'll do a 4 and a 5. Because then the sum should be 9. Difference of -1, product of 20, and quotient of 0.8. Yes. Good point, Matt. That was there. We could get a problem there, right? If, in the chat room, you point out 0 is going to cause an error on Y. So I was going to do that on the second test. Like, okay, we got some weird numbers there, so let's do a really easy one and do 3 and 0. Because, like Matt pointed out in the chat room, this is going to give us a problem because we can add things with 0, we can subtract 0, we can't divide by 0. That gives us an issue. So before long, we will see multiple ways to deal with this. You'll want to deal with that. You'll always want to find some way to deal with it. At this point, we haven't seen any type of selections or loops where we can keep asking for another number. So in parentheses, I'm just going to put do not enter 0. That way the problem is dealt with. It's in the prompt not to enter a 0. Not the programmer's fault if the user gives us bad data and the program crashes, right? So, but we want to check things repeatedly and look for stuff like that and try to deal with it when you can. And as we learn more about those 4 constructs we talked about earlier, the problem solving things, we will see more and more ways to do that. So we saw some small numbers. Let's enter some big numbers this time. I'm just going to mash the digits a bunch of times, sort of more of the thing that we would need a calculator for. There it is. That seemed to take a long time to pull up. I'm mash the digits a bunch of times and wait for that to run through, and we get some answers. I guess those seem reasonable. I heard big numbers. I don't know off the top of my head, I'm not checking them, and just run your program over and over again to check it and make sure it works. I always want to check good input, bad input, and nonsense. Things that make sense to enter, like the 4 and the 5 that we can confirm, the first one we did. Bad input, like a 0 for the second number to see what happens when it crashes. Because at this point it just crashed. We're just going to let it crash and handle it in the prompt. And include in that prompt message, don't enter a 0. And we'll let it crash if they enter a 0, but we'll see better ways to deal with that before long. And you also want to enter nonsense. Right? What happens if somebody just gives us utter nonsense here, like yellow and blue? It added them together. We got the first answer, right? Because the plus sign has more than one meaning. Our term for that is overloaded. We overloaded the plus sign with multiple meanings. But subtraction is not overloaded in that way. We can't combine strings that way. So you always want to check and see what happens on in the different situations. Was it Madeline here? I guess it must have got cut off or something. Okay, so that's that in Raptor. Let's look at it in Python as well, because we're kind of using both languages since the book included it. This isn't a language. This is a low-code solution is the term for it. But that's a mouthful. So whenever I slip up and say language, I hope you all realize what I'm talking about, and that drawing a flowchart isn't actually a language. So we saw it in the flowchart in the low-code solution. So let's look at it in Python as well. So the flowchart, like we saw earlier, the flowchart does allow us to generate the thing in a programming language. I'm going to go back over to that site. It's rippleIT.com, R-E-P-L. I put the link on the homepage. Yeah, if you go to our Ivy Learn page right there in the home thing, you'll see the link for it. I'm going to create a new one in Python once it loads up. And we'll apply our algorithm the same way. So over here, I put the pseudocode stuff in comments, so I'll just follow suit and I'll copy that pseudocode over to this Python stuff so we have it there. And to make a comment in Python, a line of code that the computer will ignore, use the hash symbol or pound symbol or whatever you want to call that symbol. It has lots of the number sign, pound symbol, hashtag. There's lots of names for it, but yeah, the thing above 3 on the keyboard, that produces a comment. So it's something we can see, but the computer will just ignore that line. So it's only there for human benefit. So extra comments talking about what's going on, or in this case, showing the pseudocode. So we can do the same thing, right? Apply that same logic we just applied over in Raptor here in Python. And it's just a slightly different syntax, which is what it would be for any of our languages. The question was asked earlier, and yeah, it's a question that always shows up. It's like, which language to learn? And they're all very, very similar. So you really, to start off with, you want to pick one and learn it pretty well. And in the modern world, that is almost always Python, because everything about Python was to make it easier for the programmer. So it's a great one to start out on. But it has drawbacks. Like C++ is what's known as a strictly typed language. If we're dealing with numbers, we have to say beforehand that we're going to store a number in that spot. And then we can never put anything except the number in there. Python, we just say we have a variable, and we store a number in it, and we do math with it or whatever. But we saw that error earlier, right? Where when we tried to put a number in there, it thought it was a string, and we had to actually change it into a number. Python has to figure out what type of data we have. Do we have a number? Do we have a word or a symbol? And that slows everything down. So languages that are called open typed, where we don't have to say what type of thing we have, are much, much slower, because it takes the computer a minute to figure out what type of data it is. And like we saw at the beginning of the class when we were looking at that debugging exercise stuff put into Python, sometimes the computer will get it wrong. It'll figure out what type of data it is and then have it completely wrong so that it can't even do anything with it. So we do have to watch out for things like that. But in this case, we'll just ask for input the same way we saw. I'll even use the same names. It's probably the only time we'll use names these short on the computer, because typing's easy, right? We usually want descriptive numbers. But we have that keyword input that says we're gonna get something from the user, and it's going to be, I'm gonna put on the first one, enter the first number. But then it's that same thing we saw earlier, right? When the user types a number, well, that's coming from the keyboard. So the computer is going to think that whatever comes from the keyboard is a word. So we need to change that to a floating point number. So I'll wrap that in parentheses and change that to a float. And I like to work that way. Notice that I put that line together sort of from the inside outward, just because that's the way my mind thought about it. The computer needs it in this particular order in the end, but that's not the way my mind puts it together. So I end up working from the inside, kind of inside outward on that. And that can be very, very productive to jump around your file. Don't work top to bottom, left to right, like you would when you're putting together an essay. The final result has to be top to bottom, left to right, but that's not the order your mind's going to think about these things in. So if you can jump around and work in the same order you think about it in, it'll really improve productivity. Well, then the same thing. So I'm going to copy this line, and we're probably used to using the mouse for a lot of stuff, right? A mouse is really, really slow. So, well, if you look at a mouse, there's what, 2 to 6 buttons, but on the keyboard, there's like 100 buttons. So obviously we have a lot more control over the keyboard. So if you haven't seen it, to highlight things with the keyboard, if you hold down the shift key and use the arrows, it'll do the highlighting just like dragging the mouse around. But since I want to copy this whole line, we also have those home and end keys. Everybody familiar with those? Those are in different places on every keyboard, but somewhere you have an end key, which moves to the end of the line, and a home key, which moves to the beginning of the line. So the cursor can be anywhere in that line, right? Just click somewhere in the middle of the line. If you push end on the keyboard, that puts the cursor at the end, then hold shift and hit home, and you can select the whole line at once. So those end and home keys and holding shift make a much quicker way than the mouse to select those words. Then hit Control C, scroll down and hit Control V to paste it. And once again, minimize the chance of making a typo by only changing the things that need changed. Enter the second number. And we already saw there's kind of a criteria here, right? Do not enter 0. And then I forgot a space up here. It's going to put those words and the cursor is going to be right next to it. Probably want to start typing a space over. So remember, the computer does not know what a space is. We have to type that in exactly like we would any other letter. Inside our quotation marks is like, exactly, there is a quote mark here. And then we can do the same thing we did over there. Z is the sum of those. Z is going to be assigned whatever is stored in X plus whatever is stored in Y. Then print the same labels. The word sum plus whatever's in Z. And now once again, I'm going to scroll up, hold down the shift key, and just push down a couple times so it highlights both of those lines, and hit Control C, paste, 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 and then make these changes. So then minus, we call that the difference. Multiply, which is an asterisk. It's kind of small there on the screen. The asterisk, the thing above the 8, shift, and then the 8 key for that, and then a forward slash. So the one down near the bottom of the keyboard that goes from the bottom and slants forward. So the labels on those, forward slash and backslash, that goes off the top of the line. So here we're reading, we start at the bottom and go for the top of the line is in the forward position for that character. So that's a forward slash or just a slash. And that's usually our division thing. So the same logic, and there's a lot of similarities there in what happened, right? That's the biggest difference. Well, this one's typed and the other one was in pictures. But what, I have a thought on what is. What do y'all think the biggest difference between these two things is? I mean, they're the same number, a 4 and a 5. Oh, yeah. So what I was thinking has happened down here as well. Is this right here? Because over in Raptor, we did not have to convert that into a number. The computer did that for us. But then we have the same problem down here. Z is a number, and can only concatenate string, not number. So we need to turn that number into a string. And just like we did up here, we put float. We said we want that string turned into a floating point number. It's abbreviated. It's just str, and then wrap the number in parentheses. Does everybody see that? I'm not sure if I can change the font size here. So whenever we want to turn a number into a string, just str, and then the number that we want to turn into a string gets put inside parentheses. Or really at that point, it would be a variable. The variable we want to turn into a string gets put inside parentheses. Oh, let's see if we're 4, 5. And it looks like we have the same numbers as earlier, right? So just some basic calculator operations. And then like was stated earlier, before long, when we get to selection structures, one of the homework assignments in selection structures is to do something like this and let the user choose which operation they want to perform. Does anybody have any questions about those?
No.
So once again, I'm going to put them kind of right next to each other. I'm going to have to zoom out here a little bit here. So you see how we're doing the same thing in the low code solution and the programming language. And one last thing, if I come up here and generate VBA, a standalone, that button is a exe. Did it generate that? Yeah. So here's a Visual Basic for applications. This is the language you would use if you wanted to code a new button for Microsoft Word or PowerPoint. You had something you wanted to do and there was a button that already did it, you would use this language. But even in this other language, it should look very similar to what we were doing. Slightly different syntax, but so once again, with that question that was asked earlier, we do very similar things in all our languages. So you just want to pick one to learn and start to learn it well, and then you pick up the other ones. And similar things in our low code or no code solutions where we're putting together pictures. The way we give computers instructions always follows that same pattern. So we just need a starting point, and for the most part for us, it's going to be flowcharts and Python, because those are nice, easy to work with. Python's easy to work with. Flowcharts gives us that nice visual representation where we can see things. They'll look more interesting than just a straight line. There'll be some branches in that flow soon and look a little more interesting. But any questions about that?
Nope.
So looks like we have about 20 minutes left. That was a little longer than I meant for that to take, because I want to make sure there's plenty of lab time, because this is an active subject. We learn by doing. So that's what you want to do. As you find time, open up Raptor or some place where you can type in some Python, or just some sort of document you can type text in, a text file or a Word document, and do pseudocode and practice this with different situations, right? Different things that you might come across in your daily life. If you have a bottle of medicine that you're supposed to give your dog over the course of a week, do a little calculation on that, or and things like that to get some practice with it, because it's an active subject. We learn by doing. So that's why I wanted to try and make sure there's lab time every night while we're scheduled, and I will still be sitting here until 8:50, which is only like 20 minutes now. But make sure you're practicing this stuff, and yeah, my suggestion is to do something like we just did with the calculator over the next 20 minutes, but please spend our time for learning IT. I am here available to answer questions. So, you know, if you're a hardware person and like, I want to go do stuff with hardware and have questions about using the soldering iron, you know, I'm here to answer questions. So please spend our time learning IT. That's what we're here for. If you have any questions, let me know. I'll be sitting right here till 8:50. You can ask me questions anytime, but I know I will be sitting here in front of the computer for the next 20 minutes. Otherwise, that was it for this evening. Y'all have a great weekend. Let me know if you have any questions, and I will see you all on Monday.
Thank you.
Thank you.
Thank you.